Let's look at an application. A person got into a cabin on a Ferris wheel for a ride. 7 minutes into the ride, her seat was at the top of the wheel at the height of 40 meters. 14 minutes into the ride, she was back to the base at a height of 6 meters. A function, h of t, models her seat height during the ride. So write the function as a transformation of y equals negative cosine of x. Okay, so what are we doing here? Well, we have some scenario and we want to model the scenario such that the input is going to be how long she's been on the ride. The output will be her height. So in terms of what our points will look like, our input for the function, or the x-coordinate, will be in minutes, and then the output will be in meters. All right, so the hint is write the function as a transformation of a negative cosine function. All right, well, let's look at what I have so far. 7 minutes into the ride, her seat was at the top of the wheel for a height of 40 meters. So I have the point 7, 40, and 14 minutes into the ride, it's back to the base at a height of 6 meters. So 14, 6. So if this is a negative cosine function, let's think about what that might look like. Actually, I'm just going to draw the shape. I know it's kind of an upside down bowl. It's going to repeat, but that's kind of the main shape. So when she's at the top, that's going to be the top. She has a maximum height of 40. I'm not going to go above that. So that needs to be at a peak. And then when she comes back to the base, okay, so after she's already been up there, that happens 14 minutes into the ride, and her height is 6 meters. Okay, so now it's looking familiar for kind of what we've done before. And so what can we calculate? Well, let's think about a couple things. What would this midline be here that cuts through in the middle? Well, I can think of it as being in the middle of 40 and 6, which is really just the average. So 40 plus 6 is 46, and 46 divided by 2 is 23. And this tells me that y equals 23 is the midline. Okay, great. What about the amplitude? Well, the amplitude is just the height. So it's the difference between 40 and this line, y equals 23. So for the amplitude, I just want 40 minus 23, and that's 17. So 17 is the amplitude. Okay. If I know what the period is, then I can think about kind of what my equation is going to look like. Well, it looks like, if I just kind of think about some kind of horizontal axis down here, if this x value is 7 and this one is 14, that's half the bowl right there. And so this is a length of 7 right here. And then the other half would also be 7. And so the total length of the period should just be 14. So I'm getting that P is 14. Now what I know is that I have the equation that says, well, the period is equal to 2 pi over the absolute value of B. And here we're just going to keep B as positive to make it kind of the simplest equation that we can come up with. So this tells me that the period is 2 pi over B. And I want to set the period equal to 14, and I'm going to solve for B. So what do I get there? I get 14b is 2 pi, and so b is equal to just pi over 7. Okay, I might have everything. Now notice this says h of t, and so I want this as h of t equals, so I'm ready to write my equation. I want to model it after a negative cosine function. So the amplitude is 17, but I want a negative 17 coefficient out there, so I'm modeling it based on this upside down bowl shape. Then this is cosine. What's going to be inside? Well, what is my shift? Like normally I start an upside down bowl shape. We can think of that as x equals 0 without shifting left or right. If again, I'm starting with the upside down bowl shape, which I am. But what I notice is that that would naturally fall at x equals 0 just given these points, because if this is 740 at the top, 7, 40 here at the top, and then 7 horizontal units later, I'm at the bottom, well, just back up, right? What would this point have to be? Well, this point would have to be 0, and again, it's at the same level as when it comes back down after one rotation, so 0, 6.
Okay, so this one doesn't actually have any horizontal shift. So this is, oops, I already wrote cosine. This is going to be cosine of, okay, I need my b value, pi over 7. And I would normally have like x minus something or x plus something, but this is just going to be a plain x in here. And then my midline is 23, so plus 23. Notice I made a mistake that's really easy to make. I started off with this t here, but I put an x here just kind of out of habit. So just quickly erase that, put a t there just so it matches up. Now when I use an application like Desmos or some other calculator, sometimes it'll force you to use x, and that's fine. It doesn't know that you're using t. Outside of that, just makes it easier for it. So let's keep going. All right, determine the height of the, let's see, person 12.9 minutes after entering the cabin. So what happens here? Well, 12.9 minutes is an input, and the height is an output. So this is really just asking for the output of a function, which is really how functions like to operate. And so this isn't any solving or anything funny. It's just me replacing my input with 12.9. So I'm going to have h of 12.9 equals negative 17 times cosine of pi over 7 times 12.9 plus 23. So I'm going to get my scientific calculator on it, and I'm going to plug this all in at the same time. First, I want to make sure that I am in radian mode. So I'm in radian mode in my calculator, and then I'm going to put a negative 17 cosine. I already started the parentheses for me. I want pi, so sometimes you have to go in and find a pi. Let's see here. There's pi. Okay, back to normal. Pi divided by 7. And now I want to multiply that by 12.9, so I hit my right arrow button times 12.9, and then end with a parenthesis, and then plus 23. So I get about 8.03. Okay. We like to close this with a sentence. So determine the height. So of her seat or whatever, right? So we say an output is going to be in meters. So we'll say the height of her seat is 8.03 meters, 12.9 minutes after entering the cabin. Okay, last part. The person exited the cabin after one round. So determine when the person was at a height of 33 meters. So for one like this, this is something that we could solve with a trig equation. But if you haven't learned that tool yet, another way to do it is graphically. So what do we have here? We have two things. One is just our equation. So one equation is just here, which is y equals negative 17 cosine of pi over 7 d, or x, doesn't matter, plus 23. So we'll just make sure that that matches up with the equation that we found earlier. Yes, okay, great. And then I want to know when the height is 33 meters. Well, when the height is 33 meters, y is 33. So that's that point right there. So what this is really doing is when I find these intersecting points, then I am setting these two equations equal to and solving, but I'm doing it graphically. So what do I get when that happens? Well, I get two intersection points. And I think that makes sense, right? Somebody's on a Ferris wheel, which has a maximum height of 40 and a minimum height of 6. And these are both in meters, right? If you're just thinking about this. And then 33 meters is, say, around there. Well, then the person is going to hit that 33 meter height kind of on the way up and on the way back down. And that's what both of these points represent. Remember, the output for our function is in meters and the input is in minutes. And so I'm looking at 4.9 and about 9.1. So determine when the person was at that height. So I'll just say the person was at that height 4.9 minutes and 9.1 minutes after entering the cabin. So what we've really done is taken a scenario, modeled it with a trigonometric function, and then been able to answer a couple questions about it, right? One is if I have an input, what output do I get? And the other, we had to work a little bit harder for, right? It says, what if you have an output? What were the inputs that made that happen? And to do that, here we used a graph, so we solved it graphically. And then another tool would be to solve it just algebraically using a trigonometric equation, which we will cover later.